I'm going to start off by talking about what's the benefit of static code analysis, especially in Kotlin, right? And then I'm going to talk about a tool called Detekt. How many of you use Detekt? Oh my God, very good. So I want to talk to you about how you could set up Detekt in your code base. And then we're going to look at what happens, how it works underneath the hood. Detekt uses something called PSI, right? And we're going to learn about what that means. We're going to learn about how it uses PSI to implement, to detect many of the different code smells. And then lastly, we're going to learn about how you write your own rules using Detekt. So imagine you have this problem. I think this is a problem that many people have. Many people, they have inherited a code base, not really happy about, and it has thousands and thousands of lines of code, and it was created many, many years ago where people didn't really talk about architecture on Android, right? And your challenge is you want to convert it to Kotlin, right? So when you have that problem, you probably have legacy code base that has issues in these areas, issues in maintainability, performance, right? So let me give you examples of these issues. You may have so a long time ago, as I said, and people didn't talk about architecture on Android, you may have an activity that's doing a lot of things. It's loading, loading things from the data, it's showing things, and people over the years, they started adding more and more code, and it got to the point that you have 2,000 lines of code, and you look at it, and you're like, WTF, right? Now, so when you're converting to Kotlin, there's this term, road to Kotlin town. You want to think about these issues, right, as you're getting to Kotlin. You want to fix them, right, not just convert your code. As you go to the road to Kotlin town, you also want to, that's a good term, by the way. I'm not saying it a bad way. So as you convert things to Kotlin, you also want to be mindful of any regressions that you create in your legacy code base. For example, here is a Java class which has a nullable type. It's an adapter, and you're using that adapter somewhere in your code base. So when you use the auto-conversion tool, the infamous Control-Shift-K, right, that command, when you use that, when you convert your Kotlin file, it's going to do double banks. But the problem is that's bad, as all of you know, because it can cause a null pointer exception when it executes that line. So the right way to do it is to use the question mark syntax, right? So that a null pointer exception is not caused, right? So this is something to watch out for as you convert your code to Kotlin. Something else you want to look into is, as many of the great talks talked about, is how could you enforce Kotlin idiomatic styles, right? So you might have a POJO, which is in Java, which has fields, it has getters, right? And it has hash code and equals, right? And when you convert this to Kotlin using the auto-conversion tool, it's going to make it a regular class, right? But the right way to do it, you could collapse all this code down if it was a data class, because it will create hash code and equals for you, right? So that's something to watch out for, right, as you convert your code to Kotlin. Something else to watch out for, lastly, is having a consistent style, especially where you're working on 5 people, 10 people, and 100, right? There's an infamous, the Android Kotlin style guide that you should follow, right? And there are many styles in there that you want to enforce as you review people's PRs and they're converting things to Kotlin. So one of the styles that it has in there, this is an example of it, is that if you have something like this, it should be a single expression, right? That's one of the styles that's enforced. So you want to enforce this as you go into Kotlin. So that's the problem that we have, right? We want to find a way to enforce code quality for our legacy code. We want to find a way to analyze our Kotlin source file to determine, are you following the style guide? Are there any performance issues or code smells? So the solution that I will look into, the solution that we will look into is, this is one way to solve this problem, to approach this problem. I'm going to convert your Kotlin source file using something called PSI, which I'll get into, is going to create this tree, right? This tree which represents your source file, right? And I'm then going to analyze this tree to determine in a pragmatic way, did you follow the style guide? Are there any code smells? Are you following Kotlin idiomatic styles? That's the approach that I'm going to show you, right, how that approach works. So right now in Kotlin, there are 2 libraries. One library is called KT-lint. It's a library that does auto formatting for you, right? This is one library that takes this approach. Another library is called Detekt, which is a library that I'm going to focus on. This library not only does auto formatting, but it also looks at your code and says, is it good or bad? Like it finds code smells for you. So this is the library that I'm going to focus on. It's Detekt with a K, by the way. So how do you set this up in your code base? How do you set it up and how do you configure it? Sorry. So Detekt has a Gradle plugin. Detekt also, so there's a two-step process to set up Detekt. First, you got to configure the Gradle plugin, and then you got to create a YAML file, which is a key store value file where you specify all of your rules. So let's look into this process. First, if I have a multi-module project, which I'm sure all of you do, you're going to add this in the root Gradle file, right? You're going to specify what is the path to your root source, which is project directory, and then you're also going to specify what is the path where my YAML file is located. Now, Detekt inside of it has a YAML file with default configuration that you could use and you could customize. In order to create a default YAML file, you're going to execute this command, detect generate config. And when you execute that command, what it's going to do is it's going to copy the YAML file from its source of Detekt, and then it's going to copy it into your project, right? Let's look at what goes into this YAML file. Detekt has many rule sets that you could turn on and off. So over here, I'm specifying rule sets that I want to turn on, what rules I want to turn on, and I could also configure at a granular level like threshold, which is a limit, right? So some rules like you could pass in a regex, etc. In addition to doing that, I could specify where I want to output my report. When Detekt runs, where do I output it? What type is going to be in my report? HTML, XML, or plain? This is what the report looks like. The report tells you how many Kotlin files were analyzed, what rules did you break, right? And they're part of what rule set, right? It's going to tell you the location where you broke that rule. It's also going to give you a complexity report. It's going to compare the number of documentation you have to the number of lines of code, right? And you can configure the type of statistic that you want. Here are all examples of them, right? So another important thing, which is really, really important, you could set a maximum number of issues. So if there are 10 or more issues that fail, your build is going to break, right? You're going to have to fix those issues. And I'll speak about how you can integrate that in your workflow. You could also set weights. How important are certain rules, right? How important are they? Like 2 means that if you break rules in that complexity rule set, they add up to more, right? So fail fast, what does that mean? Fail fast means when I turn it on, if any of the rules if you violate any of the rules, right, in Detekt, Detekt will fail. You're going to have to fix them. There is no max issues. It will make max issues into 0, etc. So that's what goes into the YAML file. Now let's look at the rule sets that you could configure, right? I'm not going to look at all the rule sets. Let's look at simple rule sets around writing Kotlin idiomatic code. So one of them is for nullable types. So as you saw in the beginning, if you converted a Java file to Kotlin, it's going to add these double quotation marks, right? And you could resolve, and what it should be, you should use the question mark syntax. So there's a rule for that called unsafe call on nullable type, which guards against null pointer exceptions. So I could turn that on in my YAML file like this, and that rule is under the potential bugs rule set. When I turn that on, how do I run Detekt? I'm going to execute this command. When I execute this command, it's going to go through all my Kotlin source files. So this is what the output would look like. It's going to tell, if I break this rule, it's going to tell me where I broke it and the line number that I broke it in, right? So this is one rule. Another rule is for enforcing using optional parameters, right? So suppose you had like a Java file which has overloaded methods, and you converted it, it will look like this, but you could collapse this down into one function. So if you specify optional values for your parameters, you could collapse it down to one method like this. So I want to enforce a rule around this. there's a rule around it for method overloading. So you could specify this like this in the YAML file. You could turn it on. You could set the maximum number of parameters you could have in your overloaded methods. If you go above 3, it will fail. Another rule is around data classes. So as I showed you earlier, you may have a POJO, which is in Java, which has an equals and hash code. If you convert it, it's going to be a regular class. It should be a data class, right? Because it generates equals and hash code for you. So there's a rule for this that you can enforce called use data class. So I could turn it on in my, this falls under the style rule set. I could turn it on in my YAML file like this, and there's an additional configuration. If I annotate like my class with legacy class annotation or any other type of annotation, sorry, the rule, so it will exclude from like inspecting that class when it goes to check for this rule. So those are some simple rules, right? And there are many, many more rules that Detekt has for like following best practices for exceptions, not throwing generic exceptions, for like also auto formatting. So how do you now, so those are the simple rules. I won't go over all of them, but so how do you integrate that into your workflow? How do you integrate Detekt? So there's one way to do it is to create a get pre-hook commit. So before you go to commit, Detekt will run. So this was created by my colleague Brent. And this is a git commit hook that you could set up locally, right? So the next thing about now, if you're a developer who procrastinates and doesn't set this up, there's another fail-safe that you could do. On your CI, whether you're using Jenkins, Travis, or Circle CI, you could have your Detekt run first before it builds your APK and runs your tests, right? So that's a second fail-safe that you could do. So this is what we did at Vimeo, right? We integrated Detekt in this by following this process, this workflow. So that right there is how you set up Detekt, which is, I mean, uninteresting. But the interesting part is, how does it work underneath the hood? How does it enforce these rules? And when you look into that, it opens the world into something like a hidden world in the Kotlin compiler, right? So let's look at, so Detekt uses something called a PSI. What does that mean? Let's look into that. So all of you in here, I hope used Android Studio, not Eclipse. So, I mean, no offense to Eclipse people. I'm sure all of you use many of the different IDEs, right? All the JetBrains products are based on top of the IntelliJ platform. If you look at all these different IDs, they all have common features. Syntax highlighting, code refactoring, they all have a common UI, right? So all those core components are abstracted away into this IntelliJ platform. All of these different IDs are built on top of it. So the PSI is a layer in this IntelliJ platform. What it allows me to do, allows me to take a source file in any language, Kotlin, Python, you name it. I could convert that source file into a different structure, into this structure here, right? Which represents the structure of my source code, right? So this feature powers so many of the things that you use every day, from code completion, syntax highlighting, refactoring, building indexes, etc., right? So this right here is the builder that IntelliJ platform has, right? It specifies and so a certain compiler, we have to specify how it builds the PSI tree by using this interface. So let's look at that. So the Kotlin embeddable compiler, right? It's built on, it uses at the bottom, it depends on the IntelliJ platform, and it uses that builder to specify how to create this tree. So if you look at this tree, right, it represents the elements in your source file. Each node represents like a class in your, like KT class represents a class in your source file, and class body represents the body, and all these different types are inside of exposed to you by the Kotlin compiler. So Detekt depends on the Kotlin compiler. It says to the Kotlin compiler, but here's the Kotlin source file. Give me a tree, and then I'm going to analyze it and like do analysis to figure out if there are any code smells, right? So this is what I said. This is how Detekt works. It analyzes that source, that tree for these things. Now let's look at how this tree is created by the compiler internally, right? So when I give my source code to the Kotlin compiler, what happens? Many things happen, right? So in addition to creating the bytecode, right, which happens at the end, like what happens at the beginning? There are many things that happen in the beginning, the time that I give my source code, the time that bytecode gets generated. So first thing that happens is that my source code that I give to the compiler, it gets broken down into tokens, right? And then there's something called an abstract syntax tree which gets created, which represents my structure or my source file. And then on top of it, it will create the PSI tree, right? This is the process that happens when I go to the Kotlin embeddable compiler to say, give me a PSI tree. Let's look at this with an example to get a better understanding. Suppose I give this source file to my Kotlin compiler. So what the compiler will do, it's going to match each element of my source code to a token. So as you can see, class keyword matches the class, left brace. It's not going to remove all the white spaces, right? Now, how does the compiler know which token to match to? Well, inside of the compiler is something called a lexer. That's a fancy word, right? So what it does is that it provides a mapping from the keyword that you're using to the type of token that you want. KT token is inside of the Kotlin compiler. And this source code inside of something called Kotlin.flex, right? And it's based on something called JFlex, it's a very popular framework to specify a lexer. And fancy name for it provides that mapping, right? So after that process, what it's going to do is going to create an abstract syntax tree, right? Which represents the structure of my source, right? So on top of this, it creates the PSI tree. What's the difference between this tree, the PSI tree, and the AST? The PSI tree provides me with a lot more richer information. I could figure out, is the class that you use, is it a sealed class? Is it a regular class? Did you use a data class? I could figure out what annotations are you using. I can figure these things out from this tree, right, from the PSI tree. There's a plugin inside of Android Studio IntelliJ called PSI Viewer plugin, which allows you to view this tree, and it will change as you start to type things, right? And it also allows you to inspect the underlying tokens for each node in that tree, right? So this is very useful. So this process that I just outlined, you can learn more about it by going to the IntelliJ Platform SDK. If you want to learn about how do you create a PSI tree for any type of language, and it gives you tutorials to be able to extend this concept to any language, right? And it shows you how you could implement syntax highlighting, like all those features that you use for any type of language, which is what Kotlin does. So this is a really good documentation that you should read. So that's how it creates the tree underneath the hood in the Kotlin compiler. Now let's look at how do you programmatically create this tree? How do you tell the compiler, give me, here's the Kotlin source file, give me a tree. How do you use the API? And how do you traverse that tree? I need to know how to traverse that tree in order to analyze it, right? In order to figure out code smells in your Kotlin source file. So the first step to building this tree, this is what Detekt does. The first step is going to configure the compiler. Kotlin configuration is given to me from the compiler. It allows me to specify things such as, where do I do error logging? That's what I'm doing over here. That's an example of it. And then my goal is to create something called a project object, which is a concept from the IntelliJ platform. It represents my environment. I'm going to pass my configuration object to Kotlin core environment, right? I'm going to get back and tell it to give me back a project, right? So when I have this project, there's a class called PSI File Factory, which is part of the IntelliJ platform. I'm going to give the project object that I made to this File Factory class. This is the class that I'm going to use to create for any Kotlin source file PSI tree. So the first thing that I'm going to do, when Detekt runs, it gets all of the content of your Kotlin source file, right? And cleans it up, right? And then what it does is that it uses PSI File Factory and calls this method called createFileFromText. And it's going to pass in the content. It's going to pass in the language you're using, the path that you're using, There are many other more parameters that you pass in there, which I won't get into, but these are the important ones. And what it gives me back is the root node of my tree, right? PSI file. So it gives me back the root node, reference to that root node right there, right? So that's how you create a PSI tree. That's what happens inside of Detekt, right? So now you have your tree. How do you traverse this, right? And what order do you traverse in? Bottom up or top down? You need to know that, like, in order to understand, like, when you go to write your own rules, right? So inside of the Kotlin compiler, there's a class called kt_tree_visitor_void, right? And it contains methods. Every time you traverse this tree from one node to another, each of these methods are going to get called, right? And you're going to hook into them. You're going to hook into them and do some form of analysis. So first thing that I'm going to do, I'm going to create a visitor, which is what Detekt does. It's going to create a visitor. It's going to inherit kt_tree_visitor_void, right? And then I'm going to override the methods that I need to override. So I'm going to instantiate this visitor, right? And then what I'm going to do, I'm going to do PSI file, which is my root node. I'm going to call the accept method on it. When I call that method, what happens? It starts to traverse my tree, right? Right when I call that method. That accept method is available to you in all of the nodes, right? So you could recursively traverse a subgraph, like of a function, right? So let's look at the order of traversal. What is the order of traversal? Is it bottom up, top down? So I'm going to add logging statements to like these methods. The first thing that is going to traverse is going to start from the bottom. It's going to traverse the child node. It's going to traverse my function, right, first. And then what it's going to do is going to go up and traverse the root node, which is class body, right? Then it's going to go up and traverse the root node of that, which is class. Then it's going to traverse the topmost root node. Well, this is important to know, and I'll show you why, right? So that right there is how you create a PSI tree from a Kotlin source file. Much of what I talked about, there is like very little documentation around that. But the code is really clear, really good to understand, that you could like look into the compiler and like understand how to use this. So our next step, with all that knowledge, right? We looked under the hood and we looked at how things work. And it's good to look under the hood and look at how things work, so there's no surprises, right? That's what they say, right? So, now what Detekt will do is going to analyze this tree. So I want to show you how it implements two simple rules. One around data classes and another around computing the complexity in your source file, right? Let's look at two simple rules, right? With all that knowledge that we just acquired. This is a rule which enforces the idea that data classes should be simple data holders, right? It shouldn't have any extra methods besides like hash code equals, right? So here's an example of non-compliant code. This is a data class which has extra methods, a create and a post and a delete. So you have extra data, should only store data, you shouldn't have these extra methods. You can refactor it by pulling them out and creating extensions of them, right? Then your data class is reusable and it's simple data holder, right? So I want to enforce a rule around this. I want to enforce a rule, don't add any methods to your data class, right? Any extra methods. So another thing to keep in mind, if you were to override any of these methods, hash code equals, it will exclude them when it goes to like check for this rule, right? So we need a strategy to implement this, right? First thing that I need to do when I read your code, right, your source file, I need to determine what type of class are you using. Is it a data class enum? I also need to get all the methods that you have in your class, right? I also need to determine whether it's overridden or not, right? I need to do these three things. How will I do that? So the first thing I need to check is KT class, right? It provides me with an API to determine these things. Is it an enum class, object, data class, or seal class? So if you go into the compiler and you look at the source code for KT class, you're going to find these methods, right? You're going to find these methods. You're going to utilize, obviously, the isData method is the one that we need, right? So we're going to keep that in mind in the back of our heads, right? The next thing that we need to get all the declarations in your class. It could be anything. It could be properties, companion objects. I mean, yeah, it could be anything. So what I need to get are all the methods. I need to like filter out like all the other things and just get all the methods in your class. And I could do that by using the API KT class body. Now, I know what you're thinking. All of these classes, they all begin with KT. It might be annoying. I'm sorry. So this class, in its API, right, it provides me with a method called get declaration. Each declaration is represented by KT declarations, right? It gives me a list of it. So using this method, I could get all the declarations, right? And then I need to determine, when I traverse the functions, right, is the function overridden? And what you'll find is that there's a token for that. There's a token which represents that, this token over here, right? And I could check whether the method has that token, right, using this function here. So it is in the inheritance hierarchy of KT name function, right? Somewhere along it inherits like from this class, KT modify list owner, right? Which gives me the ability to check whether a function has a modifier or not. So how will we implement this rule with all that knowledge in the back of our head? First thing that I'm going to do, I'm going to override visit class, right? Because I'm interested in the class root node, like when I traverse that, when I hit that. I'm going to check, is it a data class, right? The next thing that I'm going to filter out by doing filter. So, all right, oh my God. What I'm going to do is first get all the declarations, right? First, I'm going to get all the declarations, and then I'm going to filter it. I'm going to filter it by type, KT name function. At this point, it's going to give me all the functions, take all the properties you made and put it out to the side, give me all the functions. And the next thing I'm going to do, I'm going to remove all the functions which you are overridden because it's okay, right? Right? And then what I have left over are these extra functions like create and delete post, right? And then I'm going to go through each of them, for each of them, and I'm going to report a code smell, right? So in the output, you'll see like a list of all the functions where you violated this rule. That's how this rule is implemented. It's very simple. Now, here's the thing. What's the point of this exercise? What's the point of this exercise, right? Of me explaining to you why these rules are implemented. Because you get to learn about the API, what KT class is. What is KT declaration? About this wonderful world in the Kotlin Compiler, right? You get to learn about the PSI. That's the exercise of doing this, right? The next thing that we're going to look at, how do I compute complexity? And that's a very difficult problem, right? How do I look at your source code and say, man, this, we'll already think about? So sometimes I could look at a Kotlin source file and I could determine the complexity by looking at all the code paths you're taking, right, using the PSI. That's one approach which is taken here. I won't talk about that because I don't have enough time, 11 minutes. So the other approach, the simple approach we're going to look at is determining by limiting how many methods could a file have, right? If you want to have like small, you want to follow a single responsibility principle, right, and have as little responsibility, give a little responsibility to a class. So let's look at implementation of a rule called too many functions. What it does, it sets a limit to the number of functions you could have in a file, number of top-level functions you could have, number of classes you could have, number of methods you could have in a class, number of methods you could have in an interface, right? Default is 11. You could change that. Here, imagine you have a source file which has only top-level methods, right? And you have 30+ methods, and you're like, man, something happened. So something happened in the history of your code base. So this is non-compliant code, right? You're breaking that threshold. So when this rule, checks, your Kotlin source files, this rule will like exclude classes which are deprecated. Right? That's one thing to know. So what is the strategy that we're going to use to implement this rule? Right? We are going to, this is the tree that's going to be for your Kotlin source file, right? The strategy that we're going to use is that we're going to count the number of methods, count the number of nodes, function nodes that you have. We're going to compare that against the threshold, the limit that you want to set. So I want to find out, is the method a top-level method? I'm going to use the KT name function API, which provides me with that information, right? The next thing that I need to check, do you have an @deprecated? Are you using that on your method, right? So each annotation, right, each annotation that you use is represented by KT annotation entry, right? So what it does is that there's a method which provides me to get all the nodes which are KT annotation entries on the method, right? So the API of this KT name function provides me with that ability, right? So I'm going to create an extension, right? Don't get excited. I'm creating an extension. So I'm going to create an extension to determine if a function is deprecated. And what I'm going to do, I'm going to get the type reference. I'm going to check whether it's. I'm going to do a string check. This is not the best thing to do, but it's simple, right? That's why I'm explaining it. So in my implementation, I'm going to have a variable for the limit, right? Number of top-level functions you could have in the class, right? I'm going to have a counter as I go through each of your methods. I'm going to increment it, right? So I'm going to override this method right here. I'm going to check. You have a top-level method. Is it deprecated? If it's not deprecated, then I'm going to increment this counter, right? I'm going to keep doing that until I hit my root node, which is the last node that I'm going to traverse. And then I'm going to report a code smell, right? That means that you surpass, if you surpass your limit that you specify, right? So that right there is how you implement, how Detekt implements rules, the existing rules that it has. These are not my custom rules. These are like, if you look at the source code, you'll find this implementation, right? Similar implementation. So I made it simpler for this presentation. So the exercise of that, the benefit of that, is understanding that API of the PSI. That's the benefit of it, right? Being exposed to that. The next thing, let's look at quickly, how do you write custom rules? We're going to use all that knowledge of a visitor, right? First, you want to create good practices. You want to create a module which contains all your rules, right? A separate Gradle module which contains all of your rules. And in there, I'm going to depend on this dependency, Detekt-API, which will provide me with a visitor that Detekt uses that I could inherit from. And I could hook into all of those methods that when you traverse that tree and go through each node. So the custom rule, suppose I want to write a custom rule to help you, like to prevent people from using an internal API, right? Internal package, which this is a simple example, right? And I want to give a shout out to the maintainer, like who proposed this rule. So, excuse me. So, Detekt internally has this class called rule that you're going to inherit from. First thing that you're going to do for this rule, you're going to specify an issue. You're going to give a description of the rule that you want to create. Det is like an arbitrary number, how long it would take to fix that rule, right? It's an arbitrary number. It could be less than 20 minutes. So each import is represented by this node, KT import directive, right? And the API allows me to get the import path. So very quickly, so this is the implementation of my rule, right? It's not really the best implementation, but it suffices. So I'm going to check the path. I'm going to do a string check of my path to determine are you using API.internal, right? If so, then I'm going to report the code smell. Next thing, to find rules, there's a service, the Detekt uses a service locator pattern. So in there, you're going to specify in your list over here, what are all the rules that you created so that Detekt knows about it? And then what's the last step? The last step, you're going to create a meta file in which you're going to give the path to your service locator, to your custom rule provider. Those are the steps that you need to take to create custom rules. Now, what's the benefit of everything that I talked about? Well, like you don't have to use Detekt. I mean, you could use whatever you want. I mean, I'm a messenger. So the one benefit is that everything that I talked about is in this module here, the compiler, right? So the great thing about looking into Detekt, that looking at how it works, it gives you a familiarization with how, like gives you a roadmap, like a bridge to looking into how things work inside of the compiler, right? It gives you a richer understanding of how Kotlin works, right? So in my opinion, there are 3 levels of understanding Kotlin. One is understanding the syntax, is the first level, understanding how to write effective Kotlin. The third level is optional is understanding how are the features that you use implemented at the compiler level, right? So what's worthwhile about this is that it gives you a roadmap, a bridge into the compiler, right? That's the benefit of this, right? And you might say to me, well, what's the purpose of, I don't need to know this if I'm not using it as an Android engineer. Well, if you have a passion about something, then it's worthwhile, right? So I encourage you all to look into this module, this API, and explore things in there. This is also really useful if you want to create plugins, IntelliJ plugins. So this is documentation that you can look at. At Kotlin Conf, there will be really a lot of talks around this, right? Around how do you create IntelliJ plugins. There will also be the talk, similar talk like mine, but be better than mine, on static code analysis from one of the maintainers, right? So I hope, there's one thing I would like you to get from this presentation that I hope you got is, there's an unexplored world in the compiler, the PSI, that I think you should explore on your own, it's give you a better understanding of the compiler, right? So I want to thank you all for sitting through that and looking at your phones. Just kidding. Thank you. Thank you for listening to me. My first talk, thank you.